This is Biddeford High School Graduation Standard A1.2, one variable inequalities, level 3 and 4 notes. So, learning target for level 3. I can solve inequalities in one variable using multiple steps. Okay? So similar to A1.1 where the level 3 there was to solve equations using multiple steps, here we're doing the same thing except we're using inequalities instead. Okay? Okay, so when multiplying and dividing inequalities, there's one important rule. Whenever we multiply or divide by a negative coefficient, we must flip our sign. Okay, so in our last step when we're solving an inequality, okay, let's say our variable is being divided by some negative number or multiplied by some negative number or a negative fraction. Okay? In order to get rid of that coefficient, we have to flip our sign as well. Okay? So if we multiply or divide an equation with a greater than sign by a negative number, the sign will change to a less than sign. Okay? So I'm literally just switching the direction of the sign. Okay? Pause the video if you need more time. Okay? So, conversely, if we multiply or divide an equation with a less than sign by a negative number, the sign will change to a greater than. Sign. Okay? So, if we multiply or divide an equation with a blank sign by a negative number, the sign will change to a less than or equal to sign. Okay, so if it's changing to a less than or equal to sign, this must be greater than or equal to. Okay? And then conversely, if we multiply or divide an equation with a less than or equal to sign by a negative number, the sign will change to a greater than or equal to. Perfect. So, let's take a look at some examples. So, let's take a look at these two right here. Okay? So, get my pen here. So, we have 2 times a minus 3 minus 5 times a plus 4 is greater than 8. So, just like we've been doing all along, I'll distribute. Okay, so I'll have 2 times a, which is 2a, 2 times negative 3, which is negative 6, negative 5 times a, which is negative 5a, and negative 5 times positive 4 is a negative 20. We know this is all greater than 8. So I'm going to combine my like terms here. So I have 2a here minus 5a. 2 minus 5 is negative 3a. Negative 6 minus 20 is negative 26. And we know that's greater than 8. So I'll add 26 on both sides. Okay, so negative 26 plus 26, that cancels. So I'm left with negative 3a on this side is greater than 8 plus 26. Okay, so 8 plus 26, that'll be 34. Okay, so to get the a by itself, this is what I'm talking about. Okay, we have our variable, we have an inequality, and it's being multiplied by a negative 3. Okay, so our coefficient is negative 3. So in order to get rid of the negative 3, we have to divide. Okay, so my negative 3's cancel. So I'll go right over here. So I'm left with a. Let me write over here. I have negative 34 over 3. You can find the decimal for that as well. Okay, but one thing I want to highlight right here. Okay, we had this sign right here. We had a greater than sign. But we divided by a negative, so we're going to change it to a less than sign. Okay, just flip the direction of it. So this is our solution right here. A can be any number that is less than negative 34 over 3. So just as a quick graph here, let's say I put negative 34 over 3 right here. Okay, it's going to be an open circle. Okay, and it's all numbers that are less than, so we're going in this direction. Perfect. Okay, so let's take a look at the next one. So, trying to get b by itself, of course, so I'm going to get rid of this 2 first. So I'll subtract 2 on both sides. Positive 2 minus 2, that cancels. So I'll distribute this as well while I'm simplifying things. So I have 3 times 5b. I know that is 15b. And I have 3 times negative 3, which is minus 9. Again, this is all over 7. Okay, and I have less than or equal to 8 minus 2, which is 6. Okay, so now I'm just going to proceed like I normally do. I have a 7 in my denominator right here. So in order to get rid of that 7 that is being divided, I'm going to multiply by 7 on both sides. So my 7's over here, they cross out. I'm left with 15b minus 9 is less than or equal to 6 times 7, which is 42. Okay, so again, trying to get the b by itself, I will add 9 to both sides. Okay, so negative 9 plus 9, they cancel. So let me move right up here. I'm left with 15b is less than or equal to 42 plus 9, which is 51. Okay, so here I have a positive coefficient. Okay, 15 is a positive number. So I'll divide by 15. But because 15 is positive, I don't need to switch my sign. Okay, so my 15's cancel here. So I'm left with b is less than or equal to 51 over 15. Okay, so if I were to graph that, let me put a 51 right here over 15. Okay, and b is less than or equal to, so I have a filled in circle. And I'm heading in this direction. Some ugly numbers to start off here, ugly fractions. But anyway, doesn't mean they're wrong. So pause the video if you need more time. Okay, let's take a look at these ones. So let me change my color here. We'll go with this blue. Okay, so same exact thing. I'm going to distribute first. So I'll draw my lines. Okay, so I'm left with negative d. 3 times negative 3d is negative 9d. 3 times positive 4 is plus 12. And this is greater than or equal to negative 4 times 5d, which is negative 20d. And negative 4 times positive 3, which is negative 12. Okay, so now I'm going to combine. So I have negative d minus 9d. So that's negative 10d. Plus 12 is greater than or equal to negative 20d minus 12. Okay, so how about I add this 20d over? Okay, so these will cancel. So I have negative 10d plus 20d. Well, that leaves me with a positive 10d plus 12 is greater than or equal to negative 12. Okay, so now I'll subtract 12 on this side and subtract 12 on this side. Okay, these will cancel. I'll head right down here. So I have 10d is greater than or equal to negative 12 minus 12, which is negative 24. Okay, so to get d by itself, I have a positive coefficient of 10 here, so I do not need to flip my sign. So these 10's cancel. So I'm left with d is greater than or equal to negative 24 over 10. I can simplify that fraction, so the top number is divisible by 2, so that is negative 12. Bottom number is divisible by 2, so that is 5. So this is my solution right here. So again, if I want to graph that, which I do, I'll put negative 12 over 5 right here. I have a closed circle, and I know d is greater than or equal to negative 12 over 5, so I'll be heading in this direction. Awesome. So let's take a look at this next one. So I'll distribute. Okay, so I have 4 times 1, which is 4. I have 4 times negative 2n, which is negative 8n. Now I know this is less than negative 4 times n, which is negative 4n, and negative 4 times negative 6, which is a positive 24. Okay, so I'll add this 4n over to get my n's on one side. So these cancel. So I have 4, negative 8n plus 4n is negative 4n. And this is less than 24. So I'll subtract this 4 from both sides. So those 4's cancel. So I'm left with negative 4n is less than 24 minus 4, which is 20. So I get to this point right here. To get n by itself, I need to divide by negative 4. Negative 4 is a negative number. It's a negative coefficient. So I know ultimately I'll have to change my sign. So my negative 4's cancel here. So let me go right over here. So I have n. And before I even do the math here, I'm going to switch my sign before I forget. Okay, so I have less than, so I need to change it to greater than. And 20 divided by negative 4 is negative 5. Okay, so if I wanted to graph this, I'll put negative 5 right here. Let me add some other numbers. I'll say negative 3 and negative 7. Okay, I'm going to have an open circle because this is not equal to. And n is greater than negative 5, so I'm heading in this direction. Awesome. All right, so let's move on. Let's take a look at some special cases. So let's solve and graph this inequality right here. See what we get. Okay, so I will distribute first, like usual. So on this side I have negative 5v plus 22 is greater than or equal to negative 5 times v, which is negative 5v, and negative 5 times positive 4, which is minus 20. Okay, so I'll add 5v to both sides. Okay, so negative 5v plus 5v, that cancels. And I have negative 5v plus 5v on this side, so that cancels. Okay, so I'm left with 22 is greater than or equal to negative 20. Okay, so at this point, we have canceled out our variable. Okay, put an exclamation point. This is exciting stuff. Okay, so now we have two options. Okay, so let's first ask ourselves, is our inequality true? Okay, so is 22 greater than or equal to negative 20? Well, I hope you said yes. Okay, 22 is greater than or equal to negative 20. Okay, because this is true, oh, whoops, getting a little ahead of myself. We have infinitely many solutions. Okay? So, change this to a comma. So this can be written as all real numbers. Okay? So what this is ultimately saying is if we have infinitely many solutions or all real numbers, we could pick any number in the world for v, okay, positive or negative, plug it in to our equation up here, our inequality up here, okay, and no matter what number we plug in, our inequality will be true, okay? So what is an acceptable solution to this? I would write all real numbers. And that is good enough for me. Okay, pause the video if you need more time. Okay, so let's go to this bottom one here. Again, I'll solve. So I'll distribute. So I have 4 times 1, which is 4. And 4 times negative m, which is negative 4m. I know this is greater than 9 minus 4m. Okay, so I'll add 4m to both sides. Oh, whoops. So, cancels over here. I have negative 4m plus 4m over here, so that cancels as well. So I'm left with 4 is greater than 9. So, same thing here. We no longer have a variable. Okay, so we'll ask ourselves the same thing we did in the last problem. Is our inequality true? Okay, so is 4 greater than 9? No. Okay, 4 is not greater than 9. Okay, because this is false, we have no solutions that make this inequality true. Okay, so you could take any number for m, plug it into our inequality up here, and this inequality will always be false. Okay, and I welcome you to actually do so if you have the time. Pick any number for m, positive or negative, plug it in, and see what you get. So an acceptable answer here, you could write no solution. Okay? So, let's move on. Pause video if you need more time. Okay, so that is level 3. So now let's go to level 4. Change up my color here. Okay, so for level 4, I can use my knowledge of inequalities and apply it to compound situations when and or are not specified. Okay, so what does compound mean? So compound means something composed or made up of two or more separate elements. Okay, so if we take a sneak peek down here, we have two inequalities within one equation here. Okay, so to solve compound inequalities, we will create and solve two equations then graph both of our solutions. Okay, so pause the video if you need more time. I'll scroll down. Okay, so let's take a look at this right here. So I have a compound situation here. So this reads, actually it doesn't read, but I have a, my variable, and I know it is greater than 3, but it's also less than 7. So it's kind of sandwiched in between this 3 and this 7. So I'm going to split it up into two different ones. So let me put a blue box around this one. Okay, I'll bring it right over here. So I have a is less than 7. Okay, so I'll change colors. So now I'm going to take a look at this right here. So I have a is 3 is less than a, or a is greater than 3. So I like to have my a's on the left side. So I'm just going to flip this. So I have a is greater than 3. So now I'm going to graph these. So let's say I have 2, 3, 4, 5, 6, 7, 8. So a is greater than 3, so I have an open circle, right? Okay. So I know my line or my arrow is going to be pointing in this direction. Okay. So how about I just put a little dot here, my little pink dot, so I know I'm heading in this direction. Okay. So let me switch back. So if I have a is less than 7, okay, I'll graph that too. I know it's an open circle. I'll put a little dot over here because I know a is all numbers that are less than 7 on this part of the number line. Okay, so this is called an AND statement, as I mentioned before. So I'm trying to find a number that satisfies both of these inequalities. So I'm looking for a number that is greater than 3 and less than 7. So you're probably thinking in your head, well, 4, 5, and 6 all satisfy that. And I agree. So I'll draw a line right in between these. So for an AND statement, it's almost like we're looking for the common area, okay? Something that satisfies both of these. So this is my solution right here. Okay, let's take a look at this next one. So I'll break it up. This will be my first one. So I have v minus 3 is less than 0. Okay, to get the v by itself, I'll add 3 on both sides. Okay, negative 3 plus 3, 0. So I'm left with v is less than 0 plus 3. That's 3. Okay? So I'll circle that. Actually, I meant to circle these as well. Okay, so let me get my other color. So now I'll take a look at this part of my inequality now. Okay, so I'm going to flip this around again. So I have v minus 3 is greater than negative 4. So I will add 3 on both sides. Okay, negative 3 plus 3, that cancels. So I'm left with v is greater than negative 4 plus 3, which is negative 1. Okay, so I'm looking for a number v that is greater than negative 1, that is less than 3. So if I do negative 1, 0, 1, 2, 3, 4, 5. So v is greater than negative 1. So it's an open circle. So I know it's going to be heading in this direction, so I'll put a little dot. And v is less than 3. So again, another open circle right here. Put a little dot right here. So, which numbers satisfy both of these inequalities? 0, 1, and 2. Okay, so this would be my solution right here. Okay, alright, let's move on to the next one. So, sometimes they aren't written exactly like this, okay, as one big inequality, okay? Sometimes they can be broken up by the word and. That is completely okay. So, when this happens, I'll just do the same thing I did up here, just solve them individually. So, let me take a look at this one. I'll just rewrite it over here. So I have negative 4 plus p is less than or equal to 1. Okay, so I'll solve this. I'll add 4 to both sides. Okay, so negative 4 plus 4, that cancels. So I have p is less than or equal to 1 plus 4, which is 5. So I'll rewrite this one as well. So I have p over 4 is greater than 1. So I'll multiply by 4 on both sides. So p is greater than 1 times 4, which is 4. Okay, so let me put some points down here. So I'll do 2, 3, 4, 5, 6, 7, and 8. Okay, so I'll graph this one first. So p is greater than 4. So I know I'm going to have an open circle. I'll be heading in this direction. And p is less than or equal to 5. So I know I'll have a closed circle here. And I'm heading in this direction. So and statement, I'm looking for a number that's greater than 4 and less than or equal to 5. Well, of course, that's just this little section right in here. So that's your solution. Okay. All right. Let's move to this next one. I'll solve this. So I'll rewrite it, just putting my a on this side. So I have negative 7a is greater than 49. So I'll divide by -7 on both sides. So I have A, and I divided by a negative coefficient here, okay? So I need to switch my sign. It was greater than, now it's less than. And I have 49 divided by -7, which of course is -7. Okay, I'll take a look at this side now. So I have -7a is less than -56. So divide by -7 on both sides. -7 cancels there, so I have a. Again, I divided by a negative coefficient, so I'm going to flip my sign. Okay, and I have -56 minus 7. Or -56 divided by -7, which is +8. Okay, so let's take a look at this one. I will, since there's a large margin here, I'll put 8 right here, and I'll put -7 right here. Okay, so let me graph A is less than -7. So I know that's an open circle, and I know I'm heading in this direction. Okay, now let me graph A is greater than 8. Okay, well, another open circle, and that's all numbers in this direction. So this is an AND statement. So this is saying A is a number that is less than -7, but also greater than 8. Is that possible? No, it's not. You can't have a number that's less than -7 on the number line, down here, that's also greater than 8 on this side of the number line. Okay? So, what do we do here? There's no common area for our graph. So, there's no solution. Okay? Again, if that doesn't make sense, come grab me during class and I can explain a little further. Okay, pause the video if you need more time. Okay, so let's take a look at these top two. So just getting a little more complicated here. I will do this side first. So I'll rewrite it. 2x minus 4 is greater than 4x plus 10. So I'll subtract 4x on both sides. Okay, that cancels. So I have -2x minus 4 is greater than 10. So I'll add 4 to both sides. So I have -2x is greater than 14. So I know I have to divide by -2 on both sides. So -2 divided by -2, that cancels. So I'll go right over here. I have x divided by a negative coefficient, so I'll change my sign, is less than 14 divided by -2, which is -7. So I've taken care of half of it. So now I'll take a look at this side. So I have 4x plus 10 is greater than or equal to 3x minus 10. Okay, so I will subtract 3x from both sides. So that cancels. So I have 4 minus 3x, which is just x, plus 10 is greater than or equal to negative 10. So subtract 10 on this side and on this side. These cancel. So I have x is greater than or equal to negative 10 minus 10, which is negative 20. Okay, so if I go to my number line here, how about I just put negative 20? Again, this is very rough. And I'll put negative 7 up here. So let me do this one first. X is greater than or equal to negative 20. So I know it's a filled in circle. And I'm heading in this direction. If I switch colors here, I have x is less than negative 7. So I know it's an open circle. And I know I'm heading in this direction. So what's my common area? It's all these numbers right in here. So that's my solution. Okay, moving on. So let's take a look at this one. This one's a little different. In the previous problems we've done, we've had and statements. Okay, now we have an or statement. So we're just going to proceed like normal, and then once we get to the end, we'll figure out what we need to do. So I'll solve both of them like usual. So I'll take a look at this first one. I will add 4 to both sides. That cancels, so I have b is less than 7. Okay? So I'll go over here. I have b minus 2 is greater than 9, or b plus 2 is greater than 9, so I'll subtract 2. So I have b is greater than 7. Okay? So I'll put a 7 right here, 8, 9, put a 5 right here. Okay? So I have an or statement. So you might be wondering, what's the difference between and or? Basically, and has to satisfy both parts of our inequality. So we've had one big equation where we broke it up into 2 different inequalities, okay, and we found a common area. Here, with or statements, we don't need a common area, okay? It's like if I went to the store and I said I need apples and oranges, or I said apples or oranges, okay? If I need apples and oranges, I need an apple and an orange at the very least. If I said I needed apples or oranges, okay, I just need one or the other, okay? So either would satisfy me. So let's take a look at this. B is less than 7. So I know it's an open circle. So B is less than 7. That's everything in this direction. Okay? So over here I have B is greater than 7. So again, I have my open circle here. B is greater than 7. So that's all numbers in this direction. So taking a look at this, B can be any number on the number line in order to satisfy both of these equations, except 7. It can be anything except 7. Okay, so this is my solution right here. Okay, and let me very quickly just circle all these answers. I hope you did as well, just so we don't get confused. Okay, so pause the video if you need more time. Okay, let's look at these ones up here. Almost done. I know it's a long video. Okay, so I'll solve this part. I have an OR statement, so I have 10 minus 9n is less than negative 44. So I'll subtract 10. Okay, these cancel right here, so I have negative 9n is less than negative 54. So I'll divide by negative 9 on both sides. Negative 9's cancel. So I have n. Again, I divided by a negative 9, so I need to flip my sign. So it was less than, now it's greater than. Negative 54 divided by negative 9, which is positive 6. Okay? So halfway done. Change my color. So negative 7n plus 8 is greater than or equal to 71. So I will subtract 8 on both sides. So these 8's cancel. So I have negative 7n is greater than or equal to 71 minus 8, which is 63. So I'll divide by negative 7 on both sides. These negative 7's cancel, so I have n is greater than or equal to 63 divided by negative 7, which is negative 9. Okay, so let me graph this one. How about I put negative 9 right here, and I put 6 right here. Actually, before we actually do that, I made a little mistake here. So hopefully you caught it. Okay, we divided by a negative 7 right here. Okay, so we had negative 7n is greater than or equal to 63, divided by negative 7. So again, I agree n, and we have negative 9 here, but I forgot to flip my sign. So let's do it now. So always go back and double check your work, okay? I'm looking for quality, not quantity. Okay? So I have n is less than or equal to negative 9. So I know that's a filled in circle, and it's heading this way. So I also have n is greater than 6. So I know that's an open circle, and that's heading that way. So is this an okay solution? Does this work? Yes. Okay? I'm just trying to satisfy one equation or the other one. Okay? So this is perfect right here. So moving on, let's do this one. So I have 6p minus 9 is less than 33. So I'll add 9 to both sides. These cancel, so I have 6p is less than 33 plus 9, which is 42. Okay, to get p by itself, I have a positive coefficient, so I don't need to switch my sign. I have p is less than 7. And now let's look at the other side. Okay, I have 4p minus 1 is less than or equal to 15. So I'll add 1 to both sides. These cancel. So I have 4p is less than or equal to 15 plus 1, which is 16. So I have a positive coefficient that'll divide by. So p's all alone. Sign stays the same, less than or equal to 16 divided by 4, which is 4. Okay? So, what I'll do now, I'll put 4, 5, 6, 7, 8. Okay? So, let me do this one first. I have p is less than or equal to 4. So, it's a closed circle at 4, and I'm heading this way. Okay? So, I also have p is less than 7. So I have an open circle here. So p is less than 7. Well, that's all of these numbers in this direction. But what about 4? What about 3, 2, 1, 0, -1, -100, -1,000,000? Does that also satisfy this equation? Yes. So what I'll do, I'll just go right over top of this line. Okay, so that's my solution for that one. Okay, pause the video if you need more time. Okay, last two. Okay, so here we have an absolute value inequality. So we're going to treat these the same way that we treated our absolute value equations in level 4 of A1.1. So I'm going to try to get my absolute value or my barred expression by itself. Then I'm going to create two new equations. So since this is already by itself, I'll make one over here. So I have -7 plus n is less than or equal to 6. Okay. And I also have -7 plus n is less than or equal to -6. Okay? Again, this expression right here is 6 units away from 0 on the number line. So, since I already have my blue out, I'll solve this one right over here. So to get n by itself, I'll add 7, so these cancel. So I have n is less than or equal to 6 plus 7, which is 13. Okay, so now I'll solve this one. Again, I'll add 7 on both sides. These cancel. So I have n is less than or equal to -6 plus 7, which is 1. Okay, so let me graph these. So n is less than or equal to 1. So how about I put a 1 right here, I'll put a 13 down here. So I know that's a closed-in circle, and I'm heading that way. I also have n is less than or equal to 13. So another closed circle at 13. Going right through here, right through 1, and on my way down the number line towards the negative numbers. So this is my solution. Okay. So let's do the last one. I need to get this absolute value expression by itself, so I'll subtract 9 from both sides. Okay, so this cancels. So I have the absolute value of 2b minus 6 is greater than or equal to 25 minus 9, which is 16. Okay, so I'll create two new equations. So I'll put one over here. So I have 2b minus 6 is greater than or equal to positive 16. I'll put my other one right here. And I have 2b minus 6 is greater than or equal to negative 16. Okay, so let me solve this one. I'll add 6 to both sides. 6's cancel. So I have 2b is greater than or equal to 16 plus 6, which is 22. Okay, so I'll divide by 2 on both sides. 2's cancel. There's a positive coefficient, so I don't need to switch my sign. So I have b is greater than or equal to 11. Okay, and this one over here, same thing, I'll add 6. That cancels, add 6 over here. Okay, so I get 2b is greater than or equal to negative 16 plus 6, which is negative 10. Okay, so I'll divide by 2, divide by 2. So I have b is greater than or equal to negative 10 divided by 2, which is negative 5. So I'll go to my number line, I'll put negative 5 right here, put 11 up here. So b is greater than or equal to -5. So close circle. I'm heading this way. And I have b is greater than or equal to 11. So that's another solid dot right here, and I'm still heading this way. Okay, so that's my solution.